finish the bonding and
Yeah.
structure. This is my revision topic again. And look at the screen. Bonding. There are three main bondings in my course: ionic, covalent, and metallic. Covalent has further three versions: dative, pure covalent, and polar. So this is a good mind map to recall this important chapter, bonding. What is an ionic bond? It's a bond between a metal and a non-metal, and it is always by the transfer of electrons. So one atom loses electron and the other atom gains electron. An ionic bond is between anions and cations. So suppose that the factors affecting the ionic structure is very strong. They are oppositely charged ions, but these are very important concepts because they need in questions, especially the aesthetic question. Aesthetic questions are very important, and I hope you remember we had a discussion that there are three supporting documents. Number one, the past paper, obviously itself. Second is the number one is the marking scheme. Second is the examiner report, and third is the script, detailed examiner report, which is very helpful if you do some papers with it. Again, that marking scheme, everyone look, but examiner report helps you because you know these star questions, they actually give the problem. And definitely you need to get maximum grade in your unit 1 so you can join it with unit 2 and unit 3 also. Factors affecting the strength of the ionic bond. So what is the first factor which controls the strength of the ionic bond? It is the product of the ionic charge. So if I have sodium chloride, it's +1 -1. If I have magnesium oxide +2 -2, so the product is 1. Here the product is 4. Do you remember magnesium oxide is a very, very strong lattice? Magnesium chloride is a very strong lattice because of the reason of doubly charged ions. What is the second feature? Sum of ionic radii. How much ions are far away? If the ions are very close, ionic bond would be very strong. So these are the two important features. Now we talk about the group 1. So the example is all-time famous. Sodium loses one electron and becomes sodium ion. Chlorine or magnesium, I take anyone. Suppose I take magnesium, it loses 2 electron, group 2. And similarly, group 6, if I take oxide, oxygen gains 2 electrons and become O -2. Chlorine gains 1 electron and becomes Cl -1. Now, ionic bond is actually an electrostatic bond. One atom loses electron and the other atom gains electron. So it's basically an electrostatic. Look at this one, the second bond. This is calcium chloride, and it is one magnesium fluoride, which shows that one magnesium is combining with 2 fluorine. And between elements of group 1 and 6, I take sodium and I take oxygen. So there are 2 sodium atoms with 1 oxygen because 1 oxygen needs 2 electrons. Similarly, other bonds can be justified. Now, can you recall for me? I'm showing you and you have to recall with me. What are the physical properties of ionic compounds? Yes, Shahid, can you hear me?
Yeah, physical properties of
You can look at the screen always. The
ionic compounds. Okay, they
ionic
have high melting temperatures because they're in a giant lattice, ionic
and
lattice.
the ionic and the lattice attraction, electrostatic force of attraction is very strong. Now, my point is there, Shahid, that at this point, just like 2-3 weeks before the exam, you have to focus on a very important feature, which is the quality of language. You know that these are the questions where grades are compromised because many people are able to do the MCQs correctly. but the theory questions where you have to show a good quality language is needed. That is why we have to mutually discuss some quality language answers. Like that's why we are doing past paper, because good quality language is needed to reach the maximum level. What is the second property? Ionic compounds are soluble in polar solvents like NaCl, dissolve in water. They do not conduct electricity in solid, but they do conduct electricity in molten or aqueous form. When in O level, we had this chapter, electrolysis. When you put them in aqueous solution, their ions can migrate. Now, ionic radii. Cations are smaller than their parent atoms, and anions are larger than the ionic radii. Look at this trend. Look at this trend. And what was the reason for that? On going down a group in the periodic table, the
Yeah,
ions
so
become larger.
when you go down the group, the ions will become larger because there's more electrons overall, which means they
More
occupy more
shells.
shells.
Okay, number of shells. Acha, isoelectronic ion, sodium plus sodium, sorry, nitrogen minus 3 is bigger than O minus 2, is bigger than fluorine, bigger than sodium. So this is called the trends in isoelectronic. Now, a positive ion becomes smaller as it becomes positive, and a negative ion becomes bigger. What are isoelectronic ions? What are isoelectronic ions?
Yeah, isoelectronic are basically in a period when ions are formed, they gain or lose electrons. By that gain and lose, they automatically have the same number of electrons, basically all of them,
It means
in a period that.
they all actually reach the octet.
Yeah, they finish their octet.
So they form ions in the form of their octet their octets are comparable after becoming ion. A covalent bond is always between non-metal atoms. In covalent bond, the main theme is sharing of electrons. Two atoms form a shear bond, like a shear partnership. A covalent bond is an electrostatic phenomena also. Many people, when they are writing those important theory answers, they make a mistake. Sharing itself is not anything to hold the atoms in a bond. Actually, nucleus is positive and the shared electrons are negative. So again, it is a type of electrostatic attraction. It is a type of electrostatic force of attraction which hold them. So atoms share their electrons, and these electrons actually become a source of attraction between the two nuclei. Now, single and multiple covalent bonds. A single bond results from one sharing, like hydrogen is a single share. We have double bonds when there's a double sharing. We have triple bond, and the famous compound is nitrogen. Now, do you remember nitrogen is a very inert gas?
Yes, because it's normally an N2 bond. That's what.
Nitrogen to not nitrogen, is there a very strong triple covalent bond?
Yeah, simple, triple covalent, right?
Triple covalent bond, nitrogen N2 is a simple molecule. Coordinate or dative covalent bond. What's a coordinate or dative covalent bond? You can always look on the screen. In a coordinate or dative bond, the electrons of the shear bond is donated by an electron-rich system. So it means one is the donor and other is the acceptor. This is a dative covalent bond. So can you repeat what's a dative covalent bond?
Yeah.
Hmm. What is a dative covalent bond?
It is when one atom basically donates a pair of electrons.
Hmm. Acha, I again want to highlight you. Again, I want to repeat. Sorry for repeating this very because this is the point which, as a teacher, I have to repeat 2 weeks or 3 weeks before the exam. Quality of language. You have to work on it. Maybe you work one day, second day, third day. After a week, you can find some change. These are the words. Majority concepts you remember, mashallah, that's good. But when you write it in your copy, in your exam, you have to select some specific words which are our syllabus words. And that will actually lead you to the main target grade. Actually, sometimes we know what is the concept, we write it, but still people get upset. You know what happened last time in August? Results were very unsatisfactory in August, and you must have heard a large level of discussion was there on social media also, and even in Cambridge, results were very disappointing. So we have a feature of quality of language. Now, this is the concept. Concept is very simple. A shear bond is a covalent bond. We do sharing number of electrons according to the requirement of octet rule. Sometimes we need to share more, like in ammonia, we need to share more. And this sharing also remind us the concept of lone pairs. Sometimes lone pairs are left. A very famous ion is ammonium ion, which is always in discussion. Can you tell me that why there is an arrow in this ammonium ion?
Because there's a dative
It's a
pair.
dative bond, and ammonia in ammonia, nitrogen has a lone pair. Same thing. Why there is an arrow in this oxonium ion?
Dative.
Very good. Though when you make ammonium chloride, when you make, sorry, aluminum chloride is one of the most, perhaps I think so. It is one of the most repeating example. It's a dimer, two aluminum chlorides joined together, and you can see that there are two dative bonds. Why aluminum chloride? Why aluminum chloride has to do that? Because even though aluminum chloride is an ionic nature, but it converts into covalent. The reason was that polarization phenomena. Otherwise, aluminum is a metal and chlorine is a non-metal. But this is a transition compound. Transition in sense of transformation. Aluminum chloride is partially covalent. This is carbon monoxide. You can see an arrow in this diagram which shows dative covalent bond. Now, bond length or bond distance, it is the distance between the bonded nuclei. Now, bond length or bond distance is very important in the strength of the bond. Shorter bonds are very strong and longer bonds are less strong. And we need, if we have to break the bond, we need some energy, which is called bond energy. Similarly, triple bonds are very strong. In a general trend, the bond distance is inversely proportional to bond strength. Shapes of simple molecule. What is electron pair repulsion theory?
Yeah, could you say that again? Electron repulsion theory?
You can always look, it's a type of visual revision. You can always look at the screen. What is electron pair repulsion theory?
Basically, electrons in their orbitals, they exist in pairs, and when they exist in pairs, they have repulsion between them, which makes them spin around, or in electron spin, as it's called.
Right. And the shared pair of electrons and the non-bonding electrons, they naturally repel each other. Electron pair repulsion theory says that a molecule adopt a shape with minimum repulsion between electrons. For molecule with single bonds only, draw the dot and cross diagram, then show the bond pairs. And I hope you remember that the main game was lone pair. The main game changer is how many lone pairs are there. There are many magical numbers, many things are there. But I always believe that if you remember the basic structures, because naturally electrons repel each other. Now, if electron pairs bonding or non-bonding are two, the structure will be linear 180-degree. And we can see Lewis structure and molecular geometry is linear. Look at the second. If there are three bonding or non-bonding units, the structure will be 120-degree trigonal plane. And we can see any example like BF3. Look at this, four electron pairs. Now the bond angle becomes 109.5, and it's a tetrahedral structure. When there are five trigonal bipyramidal, it is having the structure you can see. If there are six, which is a rare case, but the structure will be octahedral. Octahedral means it has eight sides. Effect of lone pair on the shape of molecule. Now, can you tell me that is it right that lone pairs are more repulsive than bond pairs? You always look at the screen.
Yeah, lone pair repulsion is higher than bond pair, and higher than bond pair repulsion.
Okay, why? The reason is there. Why the reason? Because you are perfectly right. Many people remember this concept very sharply. But if you ask why lone pairs are more repulsive, then can you read it from? Can you see this point?
Because they're back to a single. Basically, it's because they're lone pairs and they're alone and they're not in a bond.
Lone pair actually means they are obedient to one nucleus, and share
Yeah.
pair have to satisfy two nuclei. So in case of two nuclei, they are more bonded, they are more localized. Lone pairs are less localized. Look the point. Repulsion between lone pair reduces the bond angle between bond pair. Each lone pair reduces the predicted bond angle pair by 2.5, a typical examiner report language. And as I say, these languages have to be improved. Each lone pair reduces the predicted bond angle between bond pair by 2.5 degree. Now this is a linear structure, non-bonding molecular structure. If I introduce a lone pair here, look at these structures, I will see that the structure will redefine itself. When there is a lone pair, look at this ammonia. Why ammonia adopt this shape? Because in ammonia, nitrogen, look at this, nitrogen has a lone pair. And then no one can forget this example, which is one of their favorite example, water. Water has two lone pairs. Shapes of simple molecules. This is sometime in the paper very challenging because PCl5 and some other compounds, they come in memory. But if they give you a new structure, then it will be a problem. So you always have to remember some basic one and you can use them to settle other ones. For example, if you remember CCl4, if you remember CCl4, you can also talk about CH4. The only problem which is there is the contribution of lone pair. Look at this, six domains, octahedral. When it is octahedral, octa means eight, but the electrons are, pairs are six. So there are two shapes added from the plane. Look at these shapes, square planar, square bipyramidal. Now, this is a list I will share with you, inshallah, and you have to learn it. This is actually it is the list of those compounds which are commonly coming in the paper. I do not need to remind you ammonia, CH4, water, and then H2O, the water, H2O, PCl5. So they are always there. Now, this is the shape, summary of the shape. If you look all of them, you have to remember the presence of lone pair. Now, what is a polar bond? First question, what is electronegativity? Please look at the screen. What is electronegativity?
Electronegativity is the ability of an atom to attract the bonding electron. It's
And it
basically
is
like,
a
yeah, fluorine, it's like, was it fluorine, right? It's the most electronegative.
element known. Okay, what are the two
Yeah.
famous trends of electronegativity? Look at the two important trends.
Oh, this one, it increases across period and decreases down a group.
Okay, now this is the sample here. Acha, electronegativity of element decreases down the group. Why? Because again the theory questions, atomic radius increases, shielding effect down the group increases, attraction of the nucleus for the bonding pair decreases. These are the three reasons. These are the three reasons of decreasing trend in electronegativity. Electronegative element increase across a period while nuclear charge increases. Atomic radius in a period left decreases. Shielding effect is almost the same. So is it right, Shahid, that shielding effect in a period is almost the same while shielding effect increases down the group?
Yeah, shielding effect would actually increase down a group, right?
Shielding effect increases down the group. You always look at the screen, but shielding
Yeah,
effect is nearly constant in a period.
yeah, because like the number of shells are still the
Yes.
same.
Okay. If the difference in electronegativity is quite large, the bond will adopt a polarity. I will ask you, for example, carbon hydrogen bond is non-polar, but carbon and chlorine bond is polar. Can you tell me why? You can always look at the screen.
Yeah, so in bonds they're only polar because they have basically different dipoles.
Is it right that a difference of electronegativity is the case if the difference of electronegativity is so large? If the difference of electronegativity is so large, the bond will be polar. And the
Polar,
difference
yeah.
of electronegativity is not much, then it will be non-polar. In a polar bond, the bonding electrons are drawn closer. It's a shift of electron cloud. Ionic and covalent bonding are the extreme of a continuum of temperature bonding. Look at this shifting cloud. Non-polar covalent bond, polar covalent bond, and ionic bond. A very good contrast between the three bonds. Full covalent, partially covalent, and full ionic. Now, polarity of a molecule is a combination of all the bond polarities and those due to any lone pair. It is possible that in a molecule, bonds are polar, but the molecule is not polar. Unsymmetrical molecule is always the concern. Linear molecules such as CO2 are non-polar. I have asked this question before also, but as a concept of revision, I will show you this. Why CO2? Why CO2 is a non-polar molecule, even though the bonds are all polar. Look at the bonds are polar. The bonds are polar, but the molecule is non-polar. Can you tell me why?
Because the dipole difference.
Because the dipoles, do they cancel out each other?
No.
They are like a physics concept, na? It's a simple
Are they
physics
can
concept.
all
Hmm.
right, in this one it's O and O because I thought you put minus on the other side. That's why.
Hmm. Acha, what about water? Why water is a polar molecule? Because
Because it has
number
a
one,
bond
bonds are
angle.
polar. Hmm. Yes, please go
Yeah,
ahead.
but it has an angle, has an angle towards it.
And due to angle, the dipoles do not cancel out each other.
Yeah.
Trigonal planar. Different atoms depending upon the molecular structure. Some molecular structures have capacity to cancel out the polarity. Look at this non-polar, look at the polar, and look at the non-polar. The game is simple in physics that the polarities, if they mutually cancel out, the molecule will be non-polar. And if the polarities do not cancel out each other, it is the polarities do not cancel out each other, it is the polar molecule. In ammonia has three polar bonds, one lone pair. The polarities do not cancel out, so ammonia is a polar molecule. Look at this diagram, and I will ask my question, the same question again, and I make an arrow for screen reference. Why ammonia is a polar molecule?
Because it has an angle in the bonds, so they don't cancel each other out.
Because the dipoles do not cancel out each other. Very good. Now we reach towards the next topic, which is very important, although many people do not give full attention. And when you see examiner reports, examiners have a complaint that people do not write in good words in this topic. Many people know that what are the intermolecular forces. They always know, everyone knows the first is permanent dipole, second is instantaneous, which is called as London forces, van der Waals forces, and the third is hydrogen bond. The examiner have a complaint that people do not describe them in wordings, in good wordings. Intermolecular forces are weak forces of attraction between molecules, while intermolecular forces are the chemical bonds that hold the atoms together within the molecule. In a workshop, he raised a very interesting example. He said people use the word molecule randomly. For example, he said, the examiner, that sometimes people even think that sodium chloride is a molecule. No, sodium chloride is not a molecule because it's an ionic product. The word molecule is used only for covalent outputs. So, intermolecular forces. Now, can you recall for me? Look at the screen. What are permanent dipole interactions? I made a circle for you to look and recall for me.
Yeah, when there's two polar molecules that will attract each other, basically, like in an example is H2O, when it
Hmm.
arranges itself
And
in the.
H2O, don't you think, Shahid, H2O example will go in hydrogen bond?
Yeah, actually, it will. That
Okay,
is true.
then take any other example. You can give me any, but do not give even any example, doesn't matter. What are permanent dipole? Remember the wording concept, huh? It's an intermolecular force of attraction between polar molecules. Simple concept. It's a force of attraction between polar molecule. Acha, what are van der Waals forces?
Van der Waals forces are the intermolecular forces or the dispersion forces that are
And
between.
are they are random. This is like a
Yeah,
flash. These attraction forces, cloud shifting is temporary, and look at this one feature, a very important feature. What does this feature mean, Shahid?
yeah. Could you repeat that again?
Can you look at the screen? What is the feature of van der Waals forces? A very important feature.
Yeah, they exist between all molecules.
Yes, all molecules all the time. What are hydrogen bond? This is the strongest intermolecular forces in which there is a hydrogen atom, and it is capable of interacting with other electronegative element. So bond energies are there for reference, and ionic, covalent, and metallic. Intermolecular forces. Look at intermolecular forces. Intermolecular forces are dipole-dipole, hydrogen bond, induced dipole-dipole, and also we sometimes call them London forces. Permanent dipole exists between polar molecule. These forces are capable to attract the bonds. They exist between some compounds which are polar, and this attraction will not always be the same. It will decrease as you have a bigger molecular size. Look at this. Both molecules are polar. Look at this. Both molecules are polar. Intermolecular forces. And it's a special case. Look at this example. It's a case where electrons are mobile, and this mobility shift electron cloud on temporary basis. Look, in the lower molecule, plus minus is there. So van der Waals forces are like jumping forces. They appear, disappear, and they can even change their polarity position.
Okay.
If such a molecule which has a temporary induced dipole is approached by another, so it is like a contagious phenomena, like a flu, for example, is contagious. So one neutral molecule is approaching a polar molecule. So dipole appear in the other molecule also. And you're a physics student, you know this is called electrostatic induction. When you bring a neutral substance near to a charged substance, it also behaves like a charged substance. London forces affect boiling point, but if you go down any group, but the main important thing I'm underlining is this. London forces or van der Waals forces depend upon the number of electrons in the atom. Number of electrons in the atom. Now look at these very important factors. As I mentioned, see the examiners complained that people do not follow this topic carefully. They have an idea, but they do not read it as a proper article. What are the factors that affect the strength of van der Waals forces? The first factor is number of electrons in the atoms. Noble gases, number of electrons. Look at the boiling temperature. When you go in this group 0, group 8, you will see the boiling point is increasing. Remember that intermolecular forces always control physical properties. Intermolecular forces always control physical properties like melting point, like boiling point, like solubility. London forces, the factor second one, size of the molecule. And you have to see the shape. The atom, the melting boiling points of halogens increase down the group because the atom size get bigger. Size of the diatomic molecule increases. London forces between the molecules become stronger. You can see this example. Now see the melting point and boiling point. So can you repeat for me? We are discussing the strength of van der Waals forces. If you go down group 7, look at this table and then answer. What is the trend in melting and boiling point?
Yeah, so the melting points would increase as well as the boiling points.
Why? Good answer, right? But why?
Because one, they get bigger and the forces between them become stronger.
Then the
LDP
London
forces
forces or van der Waals forces become
stronger.
stronger. Factors affecting the strength. The third feature, size of the molecule. So if you increase the size, you will get more van der Waals forces. Shape of the molecule is another very important factor. Some molecules have a shape which does not support hydrogen bond. Methane, ethane, propane, butane, etc. If you go down, you will see melting point and boiling point increases. But if there are branches like 2-methyl propane, you see a difference. The MPBP does not decrease, does not change as they were changing before. What is a hydrogen bond? Can you look at the screen and let me know what is a hydrogen bond?
It's bonds that basically have a hydrogen atom bonded to another
Hmm.
in
Hydrogen atom is attached with a very, look at this very important point. A very,
electronegative element.
uh, so I'm sorry, repeating this feature fourth time in the class. This is the emphasis now for the next 10 days because you are here and obviously when you change place, some thing has to be managed, but you have to concentrate on this very important feature, which is a game changer: language. Edexcel board answer language. If you improve that language, you will be very safe. Otherwise, your answer would be right. Many people write the same answer. Hydrogen bond is there when there is a hydrogen. No, when there is a partial positive hydrogen atom attached to an electronegative. Plus, look at this very important second point. Did you see that?
Lone pairs on an electronegative element.
Yes, it means how many conditions are there for hydrogen bonding. There are two conditions. Hydrogen should be attached with an electronegative element, and that electronegative element should be containing a lone pair. Look at this feature, hydrogen bonding. This is hydrogen, this is oxygen, and look at the presence of lone pair. So there are two conditions to be fulfilled for hydrogen bonding. Hydrogen chloride does not form hydrogen bond. Why? Because even though hydrogen chloride is a polar molecule, but if I write HCl in front of you like this, can you tell me, why hydrogen bond is not possible here? Hydrogen bond need a close proximity. So the molecule to molecule should be very close for hydrogen bond to establish. Water is capable of making hydrogen bonds. Due to hydrogen bonding, boiling temperature are exceptionally high. A very famous graph, look, water is at a higher position. Other hydrogen group members are lower. Why water is having such a higher boiling point? It is due to hydrogen bond. Boiling temperature of hydrides of the elements would be expected to increase because of the same reason these elements can form hydrogen bond. Factor influencing the choice of solvent. Highly polar solutes such as ionic salts, they happily dissolve in water. Now here I have a question, Shahid. We had a concept: polar dissolve polar and non-polar dissolve non-polar. Do you remember this rule?
Yes, I think so.
This is a very important concept. When you put NaCl, sodium chloride, salt, when you put salt in water, water molecules break the lattice and sodium chloride is dissolved. Alcohols are soluble in, alcohol is not required, sorry. Now, I move towards the end of this chapter. What is a metallic bond?
A metallic bond is the bonding between the positive ions, cations in a metal, and the delocalized electrons. They are arranged in layers, which then allows it to be malleable and also allows it to conduct electricity.
And what about this famous entry sentence?
Yeah, I said delocalized electrons.
Okay. There is a sea of electrons.
Delocalized electrons.
Do metals, do they form giant lattice?
Yeah,
Metal structures contain giant lattice. Look at the electrons in between, and these are positive ions surrounded by a sea of electrons. Strength of metal. Strength of metallic bond depends on the following. Charge on the ion. Now, this is again an area, Shahid, which many people do not work strongly. They know metallic bond have ions, but all metallic bonds are not equally strong. Mercury is a metal, but it is a liquid. Iron is a metal which is very strong. The charge on the ion, the greater the charge, the greater the number of delocalized electrons. The size of the ion, smaller the ion, closer the electrons are to be positive, and then stronger the bond. Look at this structure, sodium and magnesium. So can you predict who will be having a stronger metallic bond, Shahid, sodium or magnesium? You can always look at the screen.
magnesium because it has more delocalized electrons per ion.
Yes, it has more delocalized electron per atom. Structure of
Yeah.
ionic compound. What type of structure they make? They make a giant lattice structure, and they are held by strong intermolecular forces of attraction. This is a giant ionic structure. It's an electrostatic force. Properties of ionic compounds, high melting and high boiling, and they have giant structure. They dissolve in water. Properties of ionic compound continued. Now, when they are molten, they can conduct electricity. Look at the right-hand diagram. Ionic compounds, ionic compounds, ionic compounds conduct electricity when they are either molten or they are dissolved in water. So that is why they are, look at this important point. Ionic compounds are brittle. What is brittle?
They easily break.
They easily break, like glass is brittle. If you try
Yeah.
to slide the layers, uh, I hope you cannot, no one actually can forget their favorite diamond. Is it a covalent structure? And the structure is
Um,
tetrahedral.
yeah, it's what? Yeah, it's carbon.
Diamond.
Yeah.
It's a structure with a very strong interaction forces. Diamond has very high melting point, very high boiling point. Look at this structure, diamond. And diamonds are, even though they're very hard, but they are transparent and they are capable of refracting the light in different angles. Silicon dioxide is another covalent structure. In new papers, you can also find these compounds, these things. Remember that it's a giant covalent structure. It's a giant covalent structure, very high melting point, and they are very hard. They are insoluble in water. What is graphite structure? You can always look at the screen. What is the structure of graphite?
Yeah, graphite is just carbon atoms. Okay, they form graphene, and then graphene forms layers on top of each other, like layers of graphene that will form graphite.
And you read the language, two-dimensional hexagonal layers with all bond angles 120. Okay, what are the important properties? It's a black or gray lustrous substance and that easily crumbles or flakes. This is graphite and it is used in pencils, This is the property of graphite, that when you write it on a paper, it leaves a mark. It is used as a lubricant also. What is, you were telling me about it, and I have to now get it to it. What is graphene?
This is just carbon bonds in hexagons.
And the layer contains of hexagonal. Look at this wording. Each layer
Hexagonal
consists of
rings.
hexagonal rings.
Yeah.
Graphene is stiffer than diamond and more than 100 times stronger than steel, but it can be stretched like rubber, the bulletproof jackets, etc. So this is the case here. Structure and properties of covalent compounds. They have normally simple covalent compounds have low melting boiling points, like Cl2, Br2 are gases at room temperature, and Cl2, Br2 are weak structures. Structure and bonding. Iodine. Iodine has been discussed a lot always. Iodine is a sublime solid. When you heat it, it doesn't become a liquid, it directly becomes a gas. Its crystals are soft and break easily. Look at this structure. This is called iodine. What about ice? Ice is a structure of water, and water structure contain hydrogen bond. Due to structure of hydrogen bond, look at this structure, ice. This is a hydrogen bonding. Look, this bonds. These are hydrogen bonds, and due to this, ice becomes a proper solid. Now, properties of metals. Look at the first property. Why metals are good electrical conductors?
Metals are because they have delocalized electrons, which are free to
Because
move
they
and
contain
means they
delocalized
can carry
electrons.
charge.
Yes. And why they are good conductors of heat?
Delocalized electrons again.
Delocalized electrons. So when you heat them, they transfer the heat very quickly. Metals have high melting point, which shows that there is a very strong attraction, and they are held by strong attractive forces. You need energy. Malleability and ductility. Malleable means turning into sheets. Ductility means turning into wire. As metals structures have layers, so they can slide over on each other. That's why they are malleable and ductile. So we are done with this chapter in detail, and this is, as I said, my target. So we will inshallah do some questions. I'm planning, if you are available,